All right, today we're working on lesson 4-2, estimate the product of a decimal and a whole number. I can use rounding and compatible numbers to estimate the product of a decimal and a whole number. So we're using estimation strategies today. Renee needs 32 strands of twine for an art project. Each strand must be 1 and 25 hundredths of a centimeter long. About how many centimeters of twine does she need? Solve this problem any way you can. So if you want an underestimate, you can be real simple there and just do 32 times 1 and wind up with 32 centimeters of twine. But you know that is going to be less than what you need. So you might want to get an overestimate here in this case, because if you're a craft person, you know that it's better to have more than not enough. So it always depends on what task you're doing. And if you wanted to, if you were actually going to the craft store, you could get something between those two. So maybe you want to get something halfway in between. And, you could try that strategy. But that's all we're doing here. Usually rounding to the nearest whole number is going to be your best strategy. And depending on what your task is, whether you can afford to have an over or underestimate. Is your estimate an overestimate or an underestimate? And if we did 1 times 32, it would be an underestimate. So we would have less than what we needed, which is not the best thing if you're doing a craft project. So let's see the next problem. What are some ways to estimate products with decimals? A wedding planner needs to buy 16 pounds of cheddar cheese. About how much will the cheese cost? You can use different strategies to estimate a product. The word about how much means that you want to estimate. So you definitely want an estimate here. And we're saying it's 200, this is so temperamental, $2.15 per pound. So one way you could do it is you could bring the 215 to the nearest whole number, which would make it a 2. You can make, instead of saying 16 pounds, you could bring that to the greatest whole number, which make that a 20. So 2 times 20 would give you 40. And would this be an over or underestimate? Well, you rounded the dollar amount down, but you rounded the number of pounds up. So I would probably guess that would be a little bit of an overestimate. Using compatible numbers, that means we're using numbers that are going to get closer to the actual answer. So in this case, 2.15 was rounded down to 2, and 16 was rounded to 15 because it's assumed that 2 times 15 equals 30. Now, some of you might not know that. So you might actually wind up doing the rounding model instead of the compatible number model, which is fine. I'm sorry, that's hopping all around. So in one way, it's going to be about $40, and the other way, about $30. This one is definitely an underestimate, and this one is a little bit probably of an overestimate. So the actual answer is going to be somewhere between both of those. About how much money would 18 pounds of cheese cost if the price is $3.95 per pound? Now for this one, if we have our equation, it's going to look a little like this. And if we bring this to our nearest whole number, it would be $4. And 18, maybe bring it to 20. So we're going to wind up with probably $80. And is this over or underestimated? That's a little hard to say because we rounded the dollar amount up. Well, no, it's not hard to say. We rounded them both up. So this is going to be an overestimate. That one is pretty clear. Both values were rounded up. So in that case, we have a overestimated what we need. So if you use, let's see, is there another way? Well, you could use 18 times, I don't know. That would probably be the most logical way to do it. Some people might do 15 times 4, but that might get you a little bit closer. Not really, it won't. So I think that's the best strategy. But as long as you get close to that, it's an estimate, so you're good. People's brains work differently. So another example, Manuel walks a total of 0.75 hundredths of a mile, that's 3/4 of a mile, to and from school each day. If there had been 105 school days so far. About how many miles did he walk? So in this case, they decided to leave the 105 alone and only get rid of the decimal. And that is a good strategy. Try to get rid of the decimal before you even mess around with the whole number when you're multiplying whole numbers times decimals and you're trying to get an estimate. Try to get rid of the decimal first. If you can leave the whole number alone, that's going to get you closer to the actual answer. So in this case down here, they decided to move both of them. And you can see these are very different. 105 and 80 are very different, but both methods will give you a reasonable answer. So they actually kept a decimal here, and they just rounded it to a compatible number because they know 8 times 100 is 8 tenths times 100 is 80. That's why they chose that one. Do a little guided practice here. There are about 20 school days in a month. About how many miles does Manuel walk each month? Write an equation to show your work. So as you're looking at that, you are going to be probably thinking, well, 20 days times 3/4 of a mile is about what? So if I do 2 times 75, they think you know what that is in your head. So 2 times 70, 0.75, I think you're going to know that, and you probably don't. Most kids, I would say, if they were trying to figure this one out at the beginning of this chapter, you would do 20 times 1 equals about 20 miles. That would be reasonable. If you did get 15 miles because you know 2 times 75 is 150 and you know where the decimal goes, good for you. But if you just rounded it like this, that would have been fine. Without multiplying, which estimate is in the another example do you think is closer to the exact answer? So as we're looking up, closer to the exact answer is probably going to be the one where we use compatible numbers. And we have talked about that. And compatible numbers are getting you closer to the actual number. Rounding sometimes gets you a little bit farther away, but it's a fine strategy, but compatible numbers will get you closer. Let's take a look at some of our work here. And again, like I said, your brains are all going to work differently. So on this one here, for number 3, I'd probably bring that maybe to a whole number. So 1 times 112 is 112. Some kids might take that and using compatible numbers, they might say, maybe I'll make that 9 tenths times 100. And if you remember our rules for multiplying by 10, 100, and 1,000, if I multiply by 100, I'm going to move the decimal 2 places. So I'm going to wind up with 90. So you might wind up with 90 on that one. If you just round, you might wind up with 112. For number 4, if I make the 104 100 and I multiply, I can use what I learned in the last lesson. So any number times 100 is going to move my decimal 2 places. So I would wind up with 33. And number 5, I could make the 9 a whole number, 9 times 80, solve a simpler problem. 9 times 8 is 72, and annex my 0 there, 720. For the next one, 0.54 is pretty close to 0.5. And if you have any number sense, you know that 0.5 equals 1/2. So what is half of 24? That's 12. If I took 12 and divided, or 24 and divided it in half, I'm going to get a 12. That one might be a stretch for some of you. For number 7, I could do 33 times 200, solve a simpler problem. 33 doubled is 66, and bring my 2 zeros over. Or I could just make it 30 times 200 and get 6,000. Either of those would be fine. For number 8, maybe I'll bring that up to 1 times 51 equals 51. That one looks good. A quick little thing before I forget. just in case you're trying to figure out how does all this annexing zero and all this other junk work. It might be a little confusing for some of you. So what I want you to pay attention to is what you already know. Always build in math on what you already know, and then you add the new stuff to it. So you already know that if you take the number 4 and multiply it by 10, we always said put the 4 down and bring a 0 over, annex a 0. But watch what you actually did. Here's the number 4. At the end of the number 4 is an invisible decimal. And what you actually did was when you multiplied by 10, you moved the decimal one place and you annexed a 0. You did what we're doing now. So if you had 32 times 100, we said write down the 32, annex 2 zeros. But what you're really doing is you're taking that 32 which has an invisible 0 or invisible decimal at the end of it, and you're moving it 2 places and you're annexing 2 zeros. So you really are you've always known how to do this. So if we're going to have 9.4 times 100, we're just taking 9.4 and we are moving the 0 1, 2 places, and we're just putting a 0 in to fill the space. But whenever you're multiplying whole numbers by 10, 100, and 1,000, you technically are moving the decimal. We just don't teach it that way because it gets a little confusing for you when you're working with whole numbers. A lot of kids don't realize that here's the year I was born, there's an invisible decimal right next to it. We just don't write numbers like that because that would be a waste of effort. So keep that in mind that whenever you multiply by 10, you move the decimal one place and throw a 0 in there if you need to. If you don't need to, because there's already some numbers there, like here, we didn't have to add 2 zeros. We just moved the decimal 2 places. So keep that in mind. You can work on your independent practice in the book or on the computer or in the interactive book or whatever you choose. Good luck.